where we're approximating solutions and we're also looking at their graphing when we graph to solve. I went ahead and did 3 similar problems to what we did in class, just to get your basic idea up here at the top. Now, if you look at the system that we have here, and you look at the types of lines that we have, these lines will never cross. They're called parallel lines. Now, these parallel lines, if you'll notice, the slopes are the same. I can't see there. The slopes here are the same, but the y-intercepts are different. If they are parallel, they'll have the same slopes but different y-intercepts. So then when we look to say what's the solution of this, you say that there is no solution because these lines will never cross. If you asked how many solutions will this system have, your answer would be none or 0. Then if you look at this particular line right here, it's actually, these 2 equations are actually the same one, especially if we added the 2x to both sides. So in our system, when it's the exact same line, we are going to call that coincidental. These are coincidental lines. And if you look and say, well, what is the solution for this system? It's actually going to be all real numbers because every number that these 2 lines have in common will be a solution. Additionally, if I ask you how many solutions there are, you would tell me that there is an infinite number of solutions. So let's look at these 2 lines. Before, with our parallel, we had the same slope but different y-intercepts. Well, when we add that 2x to both sides, we're going to have the same slope and the same y-intercept. Then we look at this last one. This last one is clearly an intersection of 2 lines. So, therefore, we can call these intersecting lines. Do not call them perpendicular because these slopes are not opposite reciprocals. If they were perpendicular, you'd have like positive 2x and negative 1/2 x. And so the slopes would be opposite reciprocals. But since they're not perpendicular. Also, if you look and I say, what is the solution? Your solution would be their point of intersection, or here at 0, negative 1. That is the solution. If I asked you how many solutions this had, you would tell me it has 1 solution. So it brings us to our last part of the lesson. When you are looking into systems this year, one of your standards asks you to approximate the value. So we're going to go ahead and graph these 2. We'll start with the first equation here, and this is a system. Our first beginning point, we begin at the negative 2, and then we're going to rise 3, run 1, rise 3, run 1. And again, you usually only need like 2 or 3 points to make a solid line. So use a straight edge because we do still want to try to be as exact as possible. And we'll put arrows at the end. Then we do the same thing here, where we begin with our B, our y-intercepts. So we're going to go up to 1, 2, 3, 4, 5. But this time our slope is down 2 over 1, down 2 over 1. And again, we're going to use our straight edge to try to get this as close as possible. But the problem is we do have 1 solution here, they intersect, but what is that solution? This is where approximation comes into play, because our solution is right here, but it's practically in the middle here of the grid lines. So if you look, this is 1 and this is 2, so it's here at about 1.5, and then if we go, we've got positive 1 here, positive 2 here, positive 3 here. It's about halfway here on our y-axis between 2 and 3, so maybe we'd say it'd be about 2.5. So we just kind of did this by eyeballing it. You kind of just look and say, where is this point the closest to? Generally speaking, you want to stick to either whole numbers or increments of a half, like I did here. I did a half. So if we wanted to make these whole numbers, then I would be inclined to round up a little bit and say that this is close to 2, 3. But really our better answer is to use 1.5 and 2.5 just because it really is like in the middle of this diagram. And again, this is where your precision is really important. If you get any of these answers, especially like up here when we know this is a solution, and you want to know if you got it correct, like you actually picked the right point, you can plug this number in for your x and this number in for your y. And if it works for both of these two systems, then we know it's a solution.